Hello everyone. Welcome to the solution of LeetCode problem 33 named Search in Rotated Sorted Array. In this problem, we are given an integer array nums with ascending orders with the distinct values. Now we have to determine whether a target is presented into the integer array or not. If the target is presented, we have to return the index number, otherwise we have to return -1. Now, the condition is the input array is rotated. That means the input array is divided into two parts and we have swapped the order. That means, suppose into the first example, let's see the first half of the array is 4, 5, 6, and 7, and second half of the array is 0, 1, and 2. Now, if we replace 4, 5, 6, and 7 after 0, 1, and 2, it will become 0, 1, 2, 4, 5, 6, 7. That means which will be a sorted. But we have cut the input array into the two halves and swapped the order. But both of the sub array is sorted here. Now here we have to determine whether the target 0 is presented here. So we can see that the target 0 is presented here, which is in the 4 number index. So we have to return 4. Now we have to write an algorithm that runs in big O of log and runtime complexity. So in any of the problem, if the algorithm basically runs in log and time complexity, most of the cases, those kind of problem can be solved using the binary search algorithm. Now let's see, how can we solve this problem into the binary search algorithm? Now, let's take this example to understand the algorithm. Here, this array is rotated. That means this array is divided into two of the halves. First half is 4, 5, 6, 7, which is sorted. Second half is 0, 1, 2, which is sorted. And the target is 0. So we have to determine whether this target presented into this entire array or not. So we can see that the target is presented here. So we have to return the index number of this. Now, how can we apply the binary search algorithm? Into the binary search algorithm, we will take two pointers. One is left, another is right. So far, so good. Now, we will take another pointer, which is m, mid. Now, at first, we have to check in which subarray the mid belongs to. The mid can be belongs to either the left subarray or can belongs to the right subarray. So at first, we have to determine in which subarray basically the mid belongs to. So here, the mid basically belongs to the left subarray. And what is the condition? The condition is pretty simple. We have to check the value of the left pointer and the mid pointer. Now, if the value of the mid is greater than the value of the left, we can say that the mid is in the left subarray. Okay. So far, so good. Now, if the mid into the left subarray, we have to determine whether the value target presented into the left subarray or not. If the value target is presented into the left subarray, we have to discard the entire right subarray and search the value into the left subarray. Now, it can be possible that the value target is not presented into the left subarray. So here, in this kind of cases, we have to search the value target into the right subarray and discard the entire left subarray as well. So this is one of the implementation of the binary search. Now, it can be possible that our mid lies into the left subarray. So here we have to check whether the value target is presented into this portion or not. If the value target is presented into this portion, we have to search the value into this portion and discard the entire left subarray here. Otherwise, it can be possible that our value does not lies into this portion. It can lies into this portion. So here, in this kind of cases, we have to discard this entire right portion and search the value into the left portion. Basically, that's how the binary search algorithm works. Now, let's dry run the input into this algorithm to understand this better. So here, the left pointer is 4, the right pointer is 2, and the target is 0. And the value of mid is 7. So we have to determine whether the target 0 lies into this range or not. But before doing that, we have to determine whether this mid lies into the left subarray or not. Here we can see that the value 7 is greater than the low pointer value 4. So we can say that it is lies into the left subarray. So far, so good. Now, unfortunately, the value target does not lie into this range. So we have to shift our left pointer to mid +1. Now, our consideration is this portion of the subarray. The left is right here, so the mid will be here. Now we have to check whether this mid lies into this subarray or not. Here, the low pointer value is smaller than the mid, so we can say that this is into the right subarray. So here, so far so good. We have to check whether the target is into the left portion of the subarray or not. Yes, the target into the left portion of the subarray, because the target 0 is presented here. So we have to discard the right portion of the subarray, which is 2. Now we have to shift our right pointer to this position. Now let's say our mid pointer is here. So we can say that the mid value is exactly equal to the target, which is 0. So we have to return the lower index. Now the low value is also 4, which is the index number. So we have to return the low index. And otherwise, after completing the iteration, we did not find the respective target. We have to simply return the -1. That's how the binary search algorithm works in big O of log n runtime complexity. I hope you understood the algorithm. Now let's move on to the code. Now, in the code, it is pretty simple. At first, we are given a function named search, which has a vector and a target as a parameter. Now, we are considering two variables, which is left and right. Now, we are running the binary search where the left value is less than is equal to the right value. Now, here, the mid is equal to the left plus right minus left divided by 2. Now, we have to check whether this mid is equal to the target. If it is, we have to simply return mid. Otherwise, we have to check if the mid lies into the left portion of the subarray. Here, the mid lies into the left portion of the subarray. Now, we have to check whether the target lies into the left portion of the subarray. If it is, we have to shift our right pointer to mid -1. That means we have to search our respective element into the left subarray. Otherwise, we have to shift our left pointer to mid +1. That means we have to search our respective element into the right subarray. Otherwise, if the mid into the right subarray, we have to check whether the value target is into the right subarray or not. If it is, we have to shift our left pointer to mid +1. That means we can search our element into the right subarray. Otherwise, we have to search our element into the left subarray. In those kind of cases, we have to shift our right pointer to mid -1. Finally, If none of the mid element is equal to the target, we have to return -1. I hope you understood the code. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.